Good morning, my dear students. Today we will continue chapter 7, Light, Shadows and Reflections. In the previous video, part 1 of this chapter, we studied about luminous objects, non-luminous objects, transparent, translucent and opaque materials. We studied about ray of light, various types of beams of light, and we also studied rectilinear propagation of light. We know that light always travels in a straight line. This property of light is known as rectilinear propagation of light. After that, we studied what is shadow, how a shadow is formed, and what are the different characteristics of shadow. So today we will see that how light helps us to see the objects around us. Let's revise what are the luminous objects and non-luminous objects. Luminous objects means the objects that emit light of its own. For example, bulb, sun, tube light, etc. If we talk about the non-luminous objects, so the objects that cannot emit light of their own, they are known as non-luminous objects. For example, marker, this whiteboard, book, notebook, table, chair. Most of the things that we see around us are non-luminous objects. Then how we are able to see these luminous and non-luminous objects? Let's try to understand. First, talk about luminous objects. I told you luminous objects are the objects that emits its own light. Okay. For example, there is bulb in the room here. So if I talk about the luminous object, when the light rays from the luminous object, when it enters our eyes, then because of which we are able to see that luminous object. But if I talk about any non-luminous object, okay, so what happens, how we are able to see the non-luminous objects? Because they cannot emit light of their own. So when the light rays fall on any non-luminous object, let's say there is table in the room. So let's say when the light rays fall on the non-luminous objects, so that object, the non-luminous object, they reflect the light. And when that reflected light falls on our eyes, when it reaches our eyes, then we are able to see that non-luminous object. Now, what is this reflection of light? Let's see. So, reflection of light simply means bouncing back of light. You might have experienced this. Take a ball, okay, hit it on the wall. So, the ball bounces back. In the same way, when light rays hits any surface, the light rays gets reflected. So, the light rays gets bounced back and changes its direction. This is known as reflection of light. Let's try to understand with the help of diagram. And I told you about the reflection of light, but the reflection of light, okay, how the light rays will be reflected, it depends on the nature of the surface. For example, here you can see this is a smooth surface and this is a rough surface. So first we will talk about the smooth surface. When the light rays fall on any smooth surface, it bounces back and changes its direction. So this phenomena of when the light rays falls on any surface, the light rays bounces off and changes the direction. This phenomena is known as reflection of light. In case of the smooth surface, here you can see the light rays are falling on this smooth surface, and after reflection all the light rays are moving in one particular direction, and even after reflection all the light rays are parallel to each other. Such type of reflection is known as regular reflection. Okay. Mirror is a very good example of smooth surface. Mirror is a smooth, highly polished surface. That's why we are able to see the image in the mirror. We will come to this point that how we can see our image in the mirror. Now try to understand about this diffused reflection. Here you can see the surface is rough. When the light rays falls on any rough surface, the light rays after reflection, they are going in the different directions, and you can see now the reflected rays, they are not parallel to each other. What is this incident ray and the reflected ray? The light rays falling on the surface is known as incident ray, and the light ray, when it is after the reflection, after hitting the surface, when the light changes its direction, it is known as the reflected ray. Okay, so these are the incident ray and these are the reflected rays. So here in case of regular reflection, you can see the smooth surface it reflects the incident rays, it reflects the rays in one particular direction, and the rays, even after the reflection, they are parallel to each other. But if we talk about the diffuse reflection, here you can see the surface is rough, because of which the rough surface, it reflects the rays in the different directions, and the light rays after reflection, they are not parallel to each other. Such type of reflection is known as diffuse reflection, and it is also known as irregular reflection. We are able to see our image in the mirror because of regular reflection. Okay, let's try to understand how it happens. When we stand in front of the mirror, what happens? We are able to see our image in the mirror. How it happens? We are also a non-luminous object. When light rays falls on our body, so light rays gets reflected by our body. And when these reflected light rays falls on the mirror, again the mirror reflects the light rays. And when those reflected light rays reaches our eyes, then we are able to see our image in the mirror. Okay, so we are able to see our image because of the reflection and because of the regular reflection, because mirror is a smooth, highly polished surface. It reflects most of the light rays falling on it. Okay, I hope now it is clear. Now coming back to the shadow. We studied that shadow is a dark region. It is formed when any opaque object it is placed in the path of the light and it blocks the path of light. So this dark region is formed. So that dark region is shadow. If we compare the image and shadow, what are the differences between the image and shadow? Let's say I am here. If I stand in front of the mirror, I will be able to see my image in the mirror. So if I talk about image has exactly the same color as that of the object. Okay, let's say I am wearing this pink shirt. So in the mirror also, in my image also, the color of the shirt will be pink. Okay, so image gives us all the details. Image gives all the details of the object, means the image is exactly same as that of the object. But if we talk about the shadows, the shadow is always dark in color. Okay, and the shadows, they shows only the outline of the object, not any other details. Okay, as you can also see here, here you can see the shadow of my hand on the whiteboard. So shadow, it only shows the outline, or we can say the shape of the object. It cannot tell the details of the object. For example, if I will stand, let's say my shadow is here on the wall. You can see here, it is just telling the outline of the object. Here you cannot see my face in the shadow. Okay, but in the image, I will be exactly same in the image. Okay, so the image gives all the details of the object, but shadow, it only shows the outline of the object. It doesn't give any other details of the object. Now, I told you that how shadow is formed when any opaque object placed in the path of the light blocks the light, because of which a dark region is formed on the screen and we are able to see the shadow. If I talk about the images, I told you images are formed when the light rays after reflection reaches our eyes. Okay, so images are formed because of the reflection of light. And when the light rays from the object, it falls on the mirror, mirror reflects those light rays. And when the reflected light rays reaches the eyes of the observer can see the image. Observer can see the image of the object in the mirror. Observer means the person who is watching, okay, who is observing, who is watching. So this was all about the type of the reflections, difference between image and shadow. Now we will talk about pinhole camera. What is a pinhole camera? A pinhole camera, it is a simple camera without any lens, and its image formation, it is based on the principle of rectilinear propagation of light. We know that rectilinear propagation of light means light always travels in a straight line. This property of light is known as rectilinear propagation of light. And the image formation of the pinhole camera is also based on this principle of rectilinear propagation of light. So constructing a pinhole camera, it's so easy. You can also make it at home. I'm going to tell you how you can make it. Okay. Take two boxes of the same shape. Okay, as here the rectangular boxes were taken. So cut one side of the each box. This is the larger box and another should be little bit smaller than the larger box. Okay, cut one side of each box. And the size of the smaller box, it should be such that it can smoothly move inside the larger box. Okay, and now cover the surfaces of these, cover all the sides of these boxes with a black chart. Now coming back to the larger box. Here in the center make a pinhole. Pinhole means make a very small hole here in the center on one side. Okay, if I talk about the smaller box, on this side, just make a cut in the center of this smaller box here. On this side, just make a cut in the center and paste tracing paper on that. Okay. Now your pinhole camera is ready. So when you will try to see any object, okay, if you want to see any object through the pinhole camera, try to see from here. Okay. Then you will be able to see any object. If any object is there in front of the pinhole camera, you will be able to see the image of that object here on the tracing paper. And the image will be inverted image. Okay. What is the meaning of inverted image? Inverted image, as you can see, this is upside down. Okay. It is inverted. Inverted means ulti image. Okay. So in the pinhole camera, inverted images formed on the here on the tracing paper. So why inverting image forms in the pinhole camera? Let's try to understand. Okay, this is the candle, the object that has been placed in the front of this pinhole camera. So what will happen? Here you can see that light from the top of the candle. Here it is moving in the straight line. It enters the pinhole and then it reaches at point A dash on the this tracing paper. Okay, it is not like that only one light is coming from this candle. For the simplicity only, I have drawn only 3 rays. Not many rays are coming. All the rays are moving in the straight line and then reaching the are moving in the straight line, entering the hole and then reaching this on this tracing paper. Okay, so for the simplicity only 3 rays has been taken so that you can understand it easily. So here also, here from the bottom part of the candle also you can see, let's say it is B point. So from the B point, the light is moving in straight line. It is entering the hole and then it is moving in straight line again and then it is reaching at the point B dash in the, it is reaching point B dash on the tracing paper. Okay, so here you can see that because here the upper part of the object, it is appearing as here on the bottom part of the this tracing paper. Okay, and here the bottom part of the object, it is, you can see it is appearing at the top part of the tracing paper. Here you can see that light travels in the straight line and how the object, how you can see when the light rays are moving from the this object, they are moving in straight line and entering the pinhole camera, and you can see here we are getting the inverted image. I hope now it is clear that why the image is inverted in pinhole camera. Okay, and you the color of the image will be same as that of the object, but the image will be inverted. If you will reduce the distance between the object and the pinhole camera, the size of the image will increase. Okay, let's say if you bring your object here, if you decrease the distance between pinhole and the object, then the size of the image will increase. Okay. Now let's talk about the real life examples of the pinhole camera. Under a tree, in the shadow of tree, you might have seen some round spots of light. What are those? That are the pinhole images of sun. In tree, there are the gaps between the leaves of tree, and those irregular gaps between the leaves of the trees act as pinholes, and when the sunlight passes through those pinholes, it forms the image of the sun on the ground. Okay, so the irregular shape gap between the leaves, it acts the pinholes, and when sunlight passes through it, it forms the image of the sun on the ground. And those round spots of the light in the shadow of the tree are the pinhole images of sun. So this was our real life example of pinhole camera. I hope now this is clear. So this was all about chapter 7. Here chapter 7 is complete. Thank you.